Alright, let's get started discussing absolute value equation and inequality special cases. Now, once you start solving a lot of absolute value equations or inequalities, you start going through the procedure without actually thinking about what you're doing. And that can get you in trouble when you isolate the absolute value and there's a negative on the other side. Okay, this can happen in a couple different ways. For instance, it can happen in an equation. The absolute value of some expression is equal to negative 5. Think about what that means geometrically. That means we're going to take the distance of some number from 0 and obtain a value of negative 5. That's just not possible. The absolute value of a number cannot be negative. It cannot be equal to negative 5. Or the absolute value of an expression cannot be negative. It just can't be equal to negative 5. So this expression, if you isolate the absolute value and the absolute value is equal to a negative, there's no solution. Now that's not the same thing as this right here. If I have the negative open absolute value x plus 3 closed absolute value equals negative 5, because I haven't isolated the absolute value yet. I would have to divide both sides by a negative first, and then I'd have absolute value of x plus 3 equals 5. But if you have the absolute value isolated and it's equal to a negative number, there's no solution to that because you can't have a distance that's negative. Okay, and here's another similar case. I have the absolute value of some expression is greater than negative 7. Now notice again I have a negative on the right hand side. But think about this. This says that what values of x are going to make this left hand side greater than a negative number. Well, the absolute value of a number is either going to be 0 or positive. And 0 is greater than negative 7, and so is any positive number. So this is actually all real values, all real numbers. X is all real numbers. It doesn't matter what value of x you place in here. You evaluate this expression, take the absolute value, it'll be greater than negative 7. For instance, you plug in 0. 2 minus 0 is 2. Absolute value of 2 is 2, which is greater than negative 7. There isn't a value you can put in here that's going to give you a negative number, much less a negative number that's less than negative 7. All right, and that brings us to a similar argument over here. The absolute value of some expression is less than negative 1. So some number's distance from 0 is less than negative 1. Well, again, the absolute value can't be negative, so it can't be less than negative 1, because in order to be less than negative 1, this side over here would have to be a number like negative 4 or negative 5, which once you take the absolute value of a number, it immediately becomes positive. So this has no solution as well. So the quick of it is, if the absolute value is isolated and it's equal to a negative, the answer is no solution. If the absolute value is isolated and it says that the absolute value is greater than a negative number, the solution is all real numbers. And if the absolute value is isolated and it says it's less than a negative number, then there is no solution to that inequality.